Assalamu alaikum. Good morning, everyone. Hope you are doing good. Grade 11 students. This is Mr. Mohammed Nader. I'm making this is a record where you can use it as a reference if you want to know how can you start your revising before the exam. So you know that you got around 5 days for studying. You need at least 4 days to be able to finish all portions. So I would suggest that you start with day 1. You can start with the knowledge part, and day 2 you can move to the reasoning part. Day 3 you can do the problem solving, and day 4 you can make a complete revision and you can review all previous exams or previous quizzes, including the midterm exam paper. So our exam will be divided into many parts. The first part will be knowledge. So we have the exam is out of 80 marks. Out of 80 we have question 1 and question 2. Question 1 will be multiple choice, and question 2 will be some different questions focusing on explanation. Then we have question 3, which is reasoning questions, and then we have question 4, which is problem solving. You will be able to finish the whole exam within 1 hour and 15 minutes, and then you got extra time to be able to revise for the exam. Now let's start with the first part of revision. So the revision, we have different slides or different material has been uploaded on Google Classroom. We have starting with knowledge and reasoning questions, and we have a specific part for periodic motion, and we have some different questions in problem solving or application part has been uploaded as well, and we'll go through all of them. Starting with this part, the periodic motion. Once I open this part of the periodic motion, you will find that there is a worksheet and all of this was answer. And this is not the only thing. Actually, you will find the record for this periodic motion. It's uploaded on Google Classroom. So I don't have to repeat this again because the record is already uploaded on Google Classroom. Now let's start with knowledge and reasoning questions. You will find here different questions with answers. And it doesn't mean that this is the only questions and answers that we have. No, we have this part and we have the periodic motion part, as well as we have the slides. You can go through it as well. So we have the first question. It's asking about thermal energy. What do we know about thermal energy? So the most important thing we need to think about thermal energy is how do we use it. It's an internal energy in any system due to random motion of the particles. So thermal energy, it is immediately linked to number of particles. So the main definition, we call it as an average kinetic energy of the particle. And you can give some explanation or the type of thermal energy where we have conduction and we have convection and we have radiation. Second question is asking about balloon. How balloon could be affected if you place it under sunlight or if you place it in a refrigerator. If you place a balloon under sunlight, it means that the temperature got increased, and in this case the particles will keep moving faster. When the particles move faster, it means that it will keep colliding with the surface of the balloon, and because of the collision with the surface of the balloon, and we know that the balloon, it is an elastic object, so the balloon will start to expand, as you can see here. If the temperature got decreased, it means that all particles will keep moving slower, which means that the particles will come closer to each other, So you will have a huge space free in the balloon. That's why this will be a free space without any particle movement. So this space will be shrink, and you will find that the balloon size will become smaller. Another question, how two muffins at the same temperature they might have a different thermal energy. Simply, if the two muffins, even with the same temperature and even with the same specific heat, if they have different size or they have different mass, it means that the total amount of heat that got absorbed by each one of them will be different than other. Imagine that we have a small muffin and a big muffin, so each one of them will have a different thermal energy due to the size or due to the mass, which means that the mass, it is one of the most important factors or parameters that we have to be able to measure the thermal energy. And we can see that from the formula where Q equal M times C times change in temperature, which means that this amount of heat, it does not depend only on temperature or a specific heat, it depends as well on the mass of the object. That's why the two muffins with different size, it will have different thermal energy. What are the conditions of thermal equilibrium? If I consider that I have a cup of tea and I place inside the cup of tea a spoon, each one of them, it has a different temperature. Yani for an example, this tea, its temperature is 100 degrees Celsius, and the spoon, it has a room temperature of 24 to 27 Celsius. But by adding both of them together after a while, the temperature will start to move or transfer from the hot object going to the cold object until both of them will be in balance. So this 100, it will become 90, and then it becomes 80, and then it becomes 70. And 24 will increase to 34, and then 35, and so on, until both of them they meet at one point where the temperature at the first object, which is a spoon, will be the same as temperature of the second object, which is tea, and at this time we call it as an equilibrium. What is the freezing point and the boiling point for different temperature scale? We have three different scales. First one is Celsius, second one is Fahrenheit, and the SI unit, it is Kelvin. The temperature or freezing point in Celsius, it is 0. However, in Fahrenheit, when you convert it, it becomes 32 Fahrenheit. And the freezing point in Kelvin is 273.15 Kelvin. And this is actually according to the conversion from one temperature scale to another temperature scale. The boiling point in Celsius, it's 100 Celsius. Boiling point of water in Fahrenheit, it's 212, but in Kelvin, adding to 100, 273.15, you will convert it to Kelvin, so it becomes 373.15 Kelvin. Compare the difference between conduction, convection, and radiation. Thermal conduction or convection or radiation, all three of them, it requires a transfer, or it means a heat transfer from one object to another. But in conduction, the heat will transfer between metals or between solid objects. So the material that we are using in conduction, it will be solid. And in convection, the heat will be transferred. Of course, you can give an example for solid like metal, a spoon, and so on. For convection, mainly the heat will be transferred through the liquid and the gases. And for radiation, the heat will be transferred through the electromagnetic waves. Like when I say, for an example, we have the sun, the heat that you are feeling from the sun, we can call it radiation. The heat which is coming from the light bulb is a radiation. The heat which is coming from fire, it is radiation, because all of them are electromagnetic waves. Here we have an important derivation where you need to derive the specific heat formula and unit. So we can say here that we know that Q equal M times C is specific heat times a change in temperature, which means that a specific heat will equal to Q divided by mass multiplied by change in temperature. So this is the formula of the specific heat. If you want to know the unit of a specific heat, it's easy because we know that the unit of heat or amount of heat it is joule, and unit of mass is kilogram, and unit of temperature is Kelvin. So the unit of a specific heat it becomes joule over kilogram times Kelvin, and we call this as an SI unit. Let's move on to an important graph. It is a relation between temperature and heat. According to this graph, we are starting from -10 until 110 degrees Celsius. As I told you earlier before, that whenever you have an ice, you keep it inside a cup of water or any glass. When you increase the amount of heat, the ice will not be converted immediately into water. It will become as an ice and water together. When you increase the temperature again, it becomes only water. When you increase the temperature again, it becomes water and water vapor. And then by increasing temperature, it becomes only water vapor. So how many different states do we have? We have 1, 2, 3, 4, 5. That's why whenever we draw a graph to make a relation between temperature and heat, we have to draw 5 lines. 1, 2, 3, 4, and 5. Each one of these lines, it represents the state of matter for water. So the first one, as you can see, it is ice. Then here, B, it is ice and water. And then here, for C line, it becomes only water. From D to E, it is water and vapor. And then here we have only water vapor from B, E until the end. So each one of these, it has a specific requirements or a specific terms. Like we can say here, if I want to know where is the specific heat of ice, it will be A, because the specific heat is known as the total amount of heat required to increase the temperature by 1 degree Celsius. So this will be the amount of heat to increase the ice by 1 degree Celsius. And here we call it a specific heat of water, and here we have a specific heat of vapor. But for B and from D to E, we call this as a latent heat. One of them is latent heat of fusion, and the other one is latent heat of vaporization. What is the heat of fusion and heat of vaporization? Heat of fusion is the total amount of heat required to change the form from solid to liquid. And heat of vaporization, it is the total amount of heat required to change the state of matter from liquid to gas and vice versa. What is the difference between first and second law of thermodynamics? We start with the first law of thermodynamics. It is known as the law of conservation of heat. Why do we call it law of conservation of heat? Because according to the first law of thermodynamics, the amount of heat cannot be created nor destroyed. It can be only transferred from one shape to another. It can be transferred from one object to another. That's why we call it a law of conservation of heat. What is the function for each of the following? Intake valve, exhaust valve, spark plug, an internal combustion engine. You will find an intake valve. It is responsible for the control of the flow of air fuel mixture. And the exhaust valve, it has a function where it allows the exhaust gas to exit the combustion engine, and then this gas will be used to make the car start to move. And the spark plug, its function is to ignite and mix both air and fuel together, then the combustion chamber is going to mix them, and then you are going to, the spark plug will ignite it, and this will make it release the energy that powers the engine. What is the function of each of the following in a refrigerator? What is the function of internal coil, condenser coil, and extension valve? The internal coil, it can be used for evaporating, we call it as an evaporating coil, and it's responsible for absorbing all heat. Imagine that you put a soup, and this soup is very hot inside the refrigerator. How come it will become a cold? It will become a cold object after a while, because the total amount of heat inside the soup, or total temperature, or all heat according to the temperature, will be absorbed by something called internal coil. It will absorb all amount of heat and will make it cold. Then this one will go inside the refrigerator for transmitting the refrigerant. What is a condenser coil? Condenser coil, it's responsible for releasing this heat that got absorbed inside the refrigerator, and it will be evaporated surrounding. You will find this condenser coil behind the refrigerator or down of the refrigerator. If you even put your hand close to this condenser coil, you will find it very hot, because it takes all amount of heat from inside the refrigerator and it will release it outside. That's why it's very hot, so you need to pay attention not to touch this part. What is the extension valve? Extension valve, it has an important function inside the refrigerator, because it it's responsible for flowing of the refrigerant inside the evaporating coil. So when you increase the flow of the refrigerant liquids inside the coil, this will increase the pressure and will make an adjustment between pressure and temperature inside the coil, and this will avoid any kind of explosion inside the refrigerator. Why there are many processes in first law of thermodynamics, you cannot see it in the second law of thermodynamics? Because simply first and second laws, they are almost against each other. They cannot exist together. First law, it says that energy cannot be created nor destroyed. It can only be transferred from one object to another. This is the first law of thermodynamics, which means that if I have 5,000 joules inside a room, this 5,000, it cannot be 5,100 or 5,200. It will remain the same. It cannot be increased, it cannot decrease. As long as it's inside an isolated system. However, the second law of thermodynamics, it says that whenever there is an opportunity for this amount of heat to be surrounded or to be released, it will immediately be released. For an example, if you are inside a room and you start to open this room, or you start to open this door of the room a little bit, you will find that the amount of heat inside the room will start to be released one by one, which means that the 5,000, it will become as a 4,000, then it will become 3,000, and so on. That's why both of them, they cannot come together, because in one of them it requires an isolated system. However, in the second one, the system will not be isolated anymore. Explain how entropy could be affected in a thermal or by a thermal energy, because the total amount of heat that will be randomly released from the room, we call it as an entropy. So whenever you have more entropy, it means that you will have more loss of energy inside the room. That's why the second law of thermodynamics is known as the law of entropy, because the entropy will keep it change based on different parameters, like what is the amount of heat that will be released and how big is the space that you are giving for this part or for the particles to leave the room. Compare between different states of matter. As you know, we have solid, liquid, and gas, and we have also plasma that we call it as an ionized gas. And you know very well that whenever solid it got heated, it will be melted and it will be converted to liquid. So we call the process where the solid convert to liquid as a melting, but when the liquid convert to solid, we call it as a freezing. We call the liquid whenever it convert to gas, we call it got evaporated. But when the gas start to condensate like humidity, we call it as a condensation. When the solid got converted into gas immediately, we call it as a sublimation process. And this process, we can see it simply in the dry ice. And when the gas converted to the solid immediately without going through the liquid stage, we call it as a deposition process. Mention 3 examples of periodic motion. We have 3 examples like pendulum in the clock, vibrating string, and the earth orbiting around the sun. What is common about all 3 of them? All 3 of them are repetitive motion. And you will find another record about periodic motion in details in the other records uploaded on Google Classroom. Please check it. Here I'm asking you to draw the amplitude in each of the following. In a spring and in a pendulum, we know that the amplitude, it is the maximum displacement traveled by the object. So if this part or this metal or pop, it got moved with high displacement, you can see the displacement here, it is more than the displacement on the other side. We call this high displacement, we call it as amplitude. On the other side, we have a spring with different extension. The highest extension we have, or highest displacement also, we call it as an amplitude. According to Hooke's law, if the applied force it got increased, the spring constant and the extension will change, and this makes sense because according to Hooke's law, F, or the amount of force or the total amount of force, is equal to minus K times X, which means that it depends on the spring constant and it depends on the extension. You will find that the relation here for the spring constant and the force, there is no relation because the spring constant, it is the quality of the spring, which means that it does not change at all. So it does not change with the spring constant. However, with extension, it will start to increase whenever we have more mass or more weight. Okay, like here, if I'm adding more weight or more force here, it means that the extension will increase. This part it got explained in the other record as well, along with the change in potential energy. The potential energy, it's equal to 1/2 times K times X squared. So if the extension got doubled, it means that I'm going to replace X with 2. So it becomes 2 squared. So it will change by 4 times. So if the potential energy or if the extension got doubled, the potential energy will increase by 4 times of the factor. Here we have how periodic time it change with the change of the length if the length is doubled. And you will find this part got explained in the other record in details to explain how extension got when the extension is different or the length of the pendulum got a change, of course the periodic time will change according to a specific relation that we have it in the other record. So we are done with this part.